Clinical death is a biological process rather than a sudden event. We often imagine a life ending like a frozen pendulum, a single moment where everything stops, but the reality is a much slower transition. To understand this transition, we look at the heart as a mechanical pump. In its baseline state, its only function is to maintain the constant vascular pressure required to move blood through the body. When cardiac arrest occurs, that pump fails. Within a fraction of a second, the internal pressure driving your circulation drops to zero. This drop in pressure causes an immediate cessation of blood flow. Without that flow, the brain is instantly cut off from its only source of fresh oxygen. The final heartbeat simply marks the start of a silent countdown, leaving the brain isolated and running on a rapidly disappearing reserve of fuel. This countdown begins in the first 15 seconds after the blood stops moving. With its fuel supply gone, the brain enters an emergency triage mode. It aggressively shuts down non-essential functions to preserve what little energy remains for its most basic cellular structures. Because maintaining consciousness is incredibly energy-intensive, the brain cuts the power to your awareness first. This rapid shutdown results in a total blackout. Even in this state of unconsciousness, the brain's physical architecture remains intact. At this early stage, the cells are still alive, and the damage has not yet become structural. This immediate loss of awareness acts as a survival mechanism, proving that the mind's lights go out long before the physical brain begins to die. As the clock reaches the 3-minute mark, the brain moves from energy conservation into a state of active starvation. This chart tracks oxygen saturation reaching zero. Individual brain cells enter a state of severe panic, physically warping as internal chemistry fails. While structural stress is severe, neural pathways haven't broken down completely. If oxygen is restored, damage can be reversed. Between 4 and 6 minutes, the brain hits its biological limit, the window where revival becomes increasingly unlikely. Crossing this threshold, cellular walls can no longer hold together. They begin to fracture and dissolve, leading to systemic breakdown of the tissue. Doctors define this dissolution as permanent brain damage. The physical hardware has degraded to a point where the biological functions of life can no longer be sustained. Biological death is ultimately a consequence of time spent without oxygen, triggered by the heart's failure, but finalized by the decay of the cells. This narrow window is why medical interventions like CPR and defibrillation are so critical. Chest compressions act as a manual pump, artificially generating the vascular pressure needed to circulate what little oxygen remains, pausing the countdown to cellular decay. Some patients revive during this critical window report near-death experiences, describing vivid tunnels of light or intense sensory anomalies. These experiences likely stem from the brain's final electrical surges. As the neurons misfire during the shutdown process, the visual and auditory cortex can interpret these erratic signals as real light or sound. This connection between electrical misfires and vivid visions highlights how every memory and personality trait depends on a continuous, uninterrupted supply of fuel. Human life exists as a fragile, active cycle. It is a process that must be renewed every second by the heart's next mechanical stroke. Subscribe for more deep dives into the hidden biological mechanisms that govern human life.